right. Does anyone actually look at these recordings I'm making? Maybe. Once. Maybe. Probably not. Possibly. Okay. All right. Let's talk about cryptography. Cryptography, I says cryptography. It's basically a way of encrypting data. Make it hard to understand. Okay. We want to be able to surf the internet with people not seeing what we're doing. Okay. That's what we're talking about here. Okay. Foundations has an extensive and multicultural approach. The Caesar cipher obviously was made in Caesar's time. Now, I don't know about you guys. Every movie I've seen about Caesar, we're talking swords, short dresses, on everybody. And they actually encrypted data back then. That's just amazing to me. It's like, wow, they actually thought of this stuff. So today it seems pretty simple, but back then, pretty. You all seen Imitation Game? If you haven't seen it, it's on Netflix. Go watch it. Everybody have Netflix in here? Isn't that like a requirement now? But now you gotta watch Imitation Game. It's amazing. There's also a book out there called Crypto, Crypto, by Stephen Levy. You need to watch this. Not watch it. Stephen Levy. Crypto. Here's the book, and it's this one right here. Excellent book. I mean, come on, it's cheap. Normally you can buy it for $5. There it is, 64 U's for 49 cents. Normally, including shipping, you're paying a whole less than $5. Okay, so basically $5 for the book. Really, really, really interesting book. It talks. You're all going to need to take the cryptography course anyway, and I will tell you, all the bonus questions are based on this book. Get the book. Think of everything we've ever done in encryption and are currently doing in story format. Like exactly how they came up with it and what happened and what made them do this. And it's really, really interesting. So I recommend getting that book and reading it. So it's pretty good. Okay. There was restrictions on exporting way back when because people were worried. Does anyone, I know you guys are pretty young. Does anyone remember when Internet Explorer first came out with 128-bit encryption? Probably don't remember that. You couldn't export outside the United States because they were worried that if it got outside, people would be encrypting stuff to the point where we couldn't break the encryption, which is kind of scary. The government's like, no, you could. PGP, Phil Zimmerman, he made PGP pretty good privacy, and the government was freaking out. They couldn't do anything against it. It's like, crap, we can't break this privacy. They told them, do not release another version of this outside the United States. So they put it on a bulletin board, and then it got sent everywhere. So, I mean, all that's listed in the book is really, really interesting stuff. Okay. We need to know what an algorithm is. That's really the math behind this. Okay. DES, which we're going to talk here in a minute, I think, but DES was based on secrecy. What do you think? Is it a good idea or a bad idea? Based something on secrecy. But secret, no one can know what the code is, no one can break it. But the problem is, no one can know what the code is, and no one can find the problems with it. So, DES works for a while, but you're going to learn about all this stuff. We encrypt data, we decrypt data. We're going to talk about key space here in a minute. We're going to talk about some of the different ciphers. We're going to talk about we're going to talk about pretty much all this. So, okay. All right. Plain text can be encrypted. So I took the word Easter and converted it to HDV, whatever the heck that was. Okay. Now they start talking about bit stream. That's where we encrypt bit by bit. If I'm a very slow typist and I want to encrypt something, a bit stream would be good. As I type, each character gets encrypted. Block cipher means I have to wait until I get a whole bunch done and then encrypt it. Okay. So that's, when I learned about networking way back when, I might have already told you this, but I was in Germany taking a class. We were using 300 baud modems, which was excessively slow. And I remember being in a classroom kind of like this, and we'd be over here in the terminal, we'd type a letter, and we could walk over there and then watch it appear on the other machine. That's how slow the network was. We could actually walk there quicker than the network could get it there. Today, a little bit quicker. Okay. Substitution cipher. That's what Caesar cipher is. It's called a monoalphabetic substitution cipher. We replaced an A with a D, and an E with an H, and so on and so forth. We replaced one letter with another. Uses a single alphabet. Very easy to break. Showed you a website that does it instantly. Okay. Polyalphabetic uses more alphabets. Okay? A little bit tougher, harder to break, but can still be done. And then this next one. So how do you pronounce that first word? Anybody? You don't want to attempt it? Oops. That first word. Vigenary. It's actually veneer cipher, but it looks like Vigenary. And it was funny because I was in a class and the teacher was like, "In the Vigenary cipher, like you did." I said, "Well, technically it's the veneer cipher." He's like, "Oh." But the veneer cipher uses 26 alphabets and a key. A little bit tougher than what you guys did. So, for instance, if I had a key and the key was ABC, okay? So that's the key. So if I want to, well, let's not go with ABC. Let's go with key. Key. The key is key, K-E-Y. So if I was going to encrypt the word dad, it would be D, and I go over here to K, so it would be N. Okay? And then E, so the A would be encrypted with E, so it would be E. Then Y, and dad again, so it would be whatever I said was a minute ago. Crap. But basically, you're encrypted with 26 different alphabets. And again, you learn about all this in the other class, but it makes it harder to learn. Okay? This was considered unbreakable for 300 years. Obviously, it looks a lot more confusing. Okay? All right. Transposition, easy to understand. We're kind of just rearranging letters. And again, we learn all about this. It's just different ways of doing it. And the whole point of encryption is, right now, does anyone know what we're using for encryption? What the best one is right now? Anybody? It's AES. Okay? So if you're setting up your router at home, set up a wireless, and you ever see the option AES, go with that one. That's the one you want to use. But we're always changing. We're always making things differently. And transposition is not bad. Substitution. Back in Caesar's time, substitution cipher was amazing. I talked about it in the other class, but really, they would actually, way back, even before Caesar's time, would shave people's heads, tattoo messages on their head, let their hair grow back, send them across to wherever they were going, shave their heads to get the message off. There was all kinds of different ways they did it to get secret messages. Okay? So, kind of cool. XOR. You need to know XOR. Okay? XOR is used for it. It's kind of a way of mixing up text. But the way XOR works is one or the other, but not both. So, if I have a 0 and a 0, so XOR again, one or the other, but not both. So a 0 and a 0 gives me a 0. A 0 and a 1 gives me a 1. A 1 and a 0 gives me a 1. And a 1 and a 1 gives me a 0. You use this extensively in encryption. When you get to that course, you're going to be using it over and over and over, and you will understand it at that point. Okay, like it says here, it's Boolean logic, using two values to get stuff done. Okay, Vernum cipher, AT&T Labs. It says uses a set of characters once per encryption project. It's kind of like a one-time pad kind of thing. Okay. There's just lots of different ways to do this. The pad values are added to numeric values and they're encrypted. There's another show out there called Hidden Figures. Anyone seen that? Excellent movie. It's about the black women that worked for it was NASA, wasn't it? NASA. Excellent movie. You all need to see. I'm kind of I like watching those kind of realistic movies, but it's funny because their jobs were doing this encryption by hand. Then they brought in a mainframe. So the people that were doing it by hand went over there and figured out how the mainframe worked, and they were actually hired to run the mainframe. It was kind of funny because they were calculating this was doing the first orbital mission around the Earth. Who was that? Wasn't John Glenn. Who was in it? Whoever the astronaut was. But basically they were trying to calculate this so the guy wouldn't die. So the first time, the girl basically did the math. It was a female person who did the math that no one would believe in her initially, but she really impressed everybody, and the astronaut was thrilled to death. Well, then they got the computer up and running. Obviously, the computer can do it better than the person. So it's funny, they show in the movie, they show the guy, we're talking literally walking up to the rocket to climb onto the rocket. He's like, what's her face? She did verify these numbers. And I'm like, well, no. Well, I think we're going to wait here until she does. Because when we're talking first day, computers just came out. Would you trust them? Heck no. So literally they had fired her. Oh, we don't need you anymore. So they're like, we need you back. So called Hidden Figures, another really, really good movie. Okay. Book-based cipher says uses Texan's book to encrypt and decrypt. Do you anyone know what one of the most popular books in the world is? Other than this guy. The Bible. Bible. And what version of the Bible? Anybody?
New Testament.
Nope.
Old Testament.
Nope. It's actually the Gideon Bible.
What?
That's what's in all the hotels. Trust me, I was in a hotel last week and I checked. Sure enough, the Gideon Bible is in the hotel room. The Gideon Bible is in pretty much every hotel room. Pretty much. So what if I used the Gideon Bible to encrypt something and told you, hey, Gideon Bible 15th edition, whatever, then you could use it to decrypt a message. So lots of cool stuff can be done that way. Okay. TV show Prison Break. You want to see that? Okay. Remember season 1 where, once you learn this stuff, you watch shows and like, oh, I like that. But he gets a message from his son. And you remember the entire right side of the page, if you read the letters all the way down the right, it basically was the secret message. Okay. So Francis Lord Bacon in France, obviously, he sent a message that said, it basically said, wait there until I come and get you. But inside there, he wrote the characters differently on certain letters. And if you read the differently written characters, it said flee. So it's kind of steganography, which get but there's just all kinds of ways to hide stuff in there. It's just amazing. U571, U-boat type stuff, that's another thing. Just lots. Hash functions are what's called one-way encryption. So I logged onto the computer here a couple minutes ago when class started. How did it authenticate that it's really me? Well, shut up. I entered my username and password. Then it took my password, it hashed it. What a hash is, think of a one-way. Okay, it's kind of like, y'all know what your windshield is in your car. If I was to smash the windshield, I get a lot of pieces. Do you agree? Do you think I could undo that? In other words, unsmash it? No, you can't. Once you break the windshield, you can't put it back together. That's what a hash function is. It's a one-way mathematical calculation. It only works one way. So when I entered my password, it hashed it, sent the hash across the network, and then my password, when I reset it a couple months ago, was stored. That hash of my password was stored over there. So when I went to log in again, it basically compares the hash. That's how it works. It doesn't actually send my password across the network. Now, is that vulnerable? Yes. Someone could capture the hash. You can't undo it. But what you can do is basically we'll say dictionary attack. Say my password is the word password. Okay? So, since my password was hashed, we know what the hash is. So what we could do is take the dictionary, go through every word in the dictionary, hash each one of those words, and find the one that matches my hash. So that's really called a dictionary attack, but there's all kinds of ways to do it. And you guys are just learning this much about it right now. You learn a lot more about it, but you talk about it in forensics, we talk about it in cryptography, we talk about it in a lot of different classes. But it's a one-way function. Okay? Algorithms are the math behind all this stuff. DES was based on secrecy. AES was based on a competition. You had a competition, hey, who can make a non-secret formula that works and is proven to be secure? So Rich and Dale did. Okay. With our algorithm, we got two different kinds, symmetric and asymmetric. Symmetric is same key. Whereas the key that I encrypt it with is the same key that I decrypt it with. Okay. So think of the same key that I locked the door is the same key I used to unlock the door. They're very fast and very good, but there's a problem with that. Anyone know what the problem might be?
You have the key you have.
Well, if you have the key, you have both sides. How do I get you the key? So you're my alter ego spy in Russia, and I'm going to send you a secret message. Obviously, I encrypted it with a key. You have to have the same key to decrypt it. I need to get you the key. So key distribution is an issue. he gets compromised in Russia, and someone steals his key. Obviously now they have my key, because it's the same key. So symmetric algorithms is same key. We have a key distribution issue. Asymmetric is different. One key to encrypt, a different key to decrypt. That's like PGP. It's like RSA, stuff like that. Much slower, though. Much slower. All right. So symmetric, secret key, private key, same key. Easy way to remember it, S for same key. Can be programmed into fast computer algorithms. It's very quickly done. But you must both have the same key. Okay. Here it is. We encrypt something. We send the courier with the key. Then they can decrypt it. But again, we got to get the key there. How are we going to get the key over to Bob over here? Okay. All right. DES is one of those. DES, Data Encryption Standard, 64-bit block, 56-bit key. Was made by IBM years ago. And it's based on the Lucifer cipher. A lot of this is in the book, but it's funny. It's based on the Lucifer cipher. And Lucifer is like devil Lucifer. And the way they got Lucifer is based on the algorithm that was called Demon, D-E-M-O-N. Makes sense. Demon became Lucifer. But actually, when IBM wrote it, they made it as a demonstration. But they couldn't handle the length of the file name, so they shorted demonstration to Demon, D-E-M-O-N, which is now devil. So really, it had nothing to do with the devil at all. But it's kind of funny stuff. But again, that book, Crypto, tells you all this. It's really, 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 and I happen to have a PDF. So if you want, but NIST adopted it, but it has been broken. It can still be used though. No, it's been broken, but it's not like you can break it in 1 second. You're not going to be able to break it as quickly as we did Easter a second ago. So if I have something that's a very short time period, lifespan, good. But again, since it's been broken, it probably won't be used anymore. S is still being used today. We encrypt using one key with DES, decrypt with a different key with DES, and re-encrypt again with the first key again with DES. And it's still being used today. A lot of VPN firewalls use it. But it is being replaced with AES, which is much quicker, better, faster, stronger, kind of like Superman kind of thing. So much better. Okay. Asymmetric. Again, all these here we talked about are symmetric, same key. Okay. Asymmetric, now we have different keys. Okay. RSA is an example of that. We encrypt with one key, decrypt with another. Let me show you one here. Let's see. I'm going to go to keystore.pgp.com. Seriously? What is it? It's got to be there. Did they name it? Did they remove it? Or no, they didn't. Oh, let's find it. Where's the darn? The heck? I know it's key. Or maybe it's key server. There it is. Keyserver.pgp.com. Okay. F-O-C-T-R-I-A. Well, okay. What do you think? L-O-U-M-B-E-D? Okay. No, seriously? Oh, name contains? Don't tell me it's expired. Please, no. Oh, you got to be kidding me. Well, I can't show you my key. It seems that my key is now gone. You have to re-verify it every so many months, and I probably missed the time period. Well, let's find someone at Rose. Let's see. Okay, there's Donovan. He's one of my students. So I can look over here at Donovan's key. Sucks I can't show you mine, but it's okay. open with... Why isn't TextPad on the list? Fine. Search for... Come on. Okay. This is Donovan's public PGP key. Okay. So, what this means is if I want to send Donovan first something securely, I download this key, which obviously anybody can get. Y'all agree anybody can get it? We just got it. Now, when I encrypt something with this key, Donovan's the only person in the world that can decrypt it because it's a public-private key pair. The public key can encrypt, the private can decrypt, or the private can encrypt and the public can decrypt. So if I encrypt something with this and send it to everybody, the only one's going to be able to open it is Donovan because he's the only one that has the matching key. Now, what if Donovan encrypts something with his private key and then sends it to me? Or actually sends it to all of us. Can we open it? Actually, we can because we have the public key. So if Donovan encrypts it with the private key, we all can decrypt it. So what good is that? Anyone, what do you think? We know who did it. We know who made the document. There's only one person who could have made the document that this key will open. In other words, it gives us authentication. So if Donovan creates a document and I open it up with this public key, it's going to say made by Donovan. And there ain't no one in the world that can make a document that's going to say that because it won't match this key. So that's PGP. And again, mine must have expired, which really sucks. It means I got to make a new one. Darn it. So, asymmetric, public-private. That's the way RSA works. RSA is used in our SSL encryption. Let's look. Let's find one. I'm in D2L right here. I'm going to click up here, and I'm going to... How do I view my stupid certificate now? I used to be able to view the certificate. Site settings, maybe?
Yeah, they changed it.
They're killing me. They are just killing me. It used to be right here. I know I was learning more, but show me the stupid certificate. Well, guys, I don't know how to show you the certificate anymore.
It just shows up with who owns it, basically.
Yeah, it's right. It's showing. Man, that sucks. I want to show it to you.
Yeah, I learned about this last semester, and I used to do it a lot to actually check it out. And they, like most browsers, recently came out with an update that changed it to where you don't actually see the certificate; you just see if it's secure or not.
Well, that sucks. Okay, let's try Firefox. See what that one does.
What do you do on Internet Explorer?
Yeah, but that's like a virus.
That's a virus in itself.
Come on, something open here. I can't believe I can't view the stupid certificate anymore. That makes me mad. Is there an option here? Username, history, settings, and more tools. That just sucks. Let's go to D2L here. Now we're in Firefox. They're making it really hard for me to show you stuff. Okay, now let's try it. There we go. Okay. It's still not showing me the certificate. There it is. View certificate. Okay. So this certificate shows me that D2L is owned by Rose State, obviously. And to get this certificate, you have to prove your identity. Okay? And we should be able to see in here the certificate version number, the serial number, and where's the protocols? So it's using shot. There it is, right here. RSA encryption. See that? This is basically telling me this is using RSA encryption. And their public key is right. Come on. There it is. There it is. There's the public key. Kind of like Donovan's key we downloaded. Here's this guy's key. Okay. And what we can do is use it to prove that's really the bank, or in this case D2L, or bank, or whoever I'm connecting to. Because to get a certificate, they had to provide it to, in this case, VeriSign, up here at the top, VeriSign Class 3, prove who they are. So now my browser can connect to them and say, yep, that's really D2L. That's why you're getting the correct thing. Now, if you look in here, this certificate expires this July. What happens after July? Anybody?
You have to re-verify?
I have to get a new key. I have to renew it. What happens if I don't? Okay. It will continue to work. It will still encrypt my data perfectly. But it's going to warn every single person, whoa, this certificate's invalid. It's expired. Okay. So it'll still work, but it has been renewed. I used to sell certificates, and I got one that was good for 10 years, which was nice. But what do you think happens if a certificate gets lost? Can you imagine having a certificate that's good for 10 years, and you misplace it, and someone steals it? Kind of a bad thing. But they have also what's called a CRL certificate revocation list, where you can say, whoa, I lost my certificate, and it marks it as a stolen one or a bad one or a lost one. So now I know I can see it in Firefox, but I can no longer see it in Chrome, at least not at the moment. Did you figure it out?
You go to the secure thing. Oh, no, this is a different version of Chrome.
Yeah, because I think mine's updated and yours isn't. Because you used to be able to double-click on it.
You have to right-click inspect, right-click on the page, go down to inspect, go over to security on the top right list of things. Go to security, might be the double arrow. Security, view certificate.
Jeez, could they make it any harder to find? Wow.
I guess it's just not something everyone's looking for.
Yes. Oh, and this whole certificate path basically is saying is who vouched for Rose State. This is called a certificate authority. In this case, it's VeriSign. VeriSign or Symantec sells certificates for $349 a year. I used to, when I would sell certificates, if I bought them from them, I paid $349. I sold them to you for $349. I could buy them from Komodo and GeoTrust for $40. See a little markup there? So, what do you think? Think they're still good? Yeah, they're totally good. It's kind of like, it's not even like a Walmart brand. It's still a totally valid certificate, but it's trusted through a different person. That's all. This one happens to come from VeriSign. There's a lot of companies you can get them for. You can get them from Komodo, GeoTrust. There's a lot of different places. It's kind of like, do you like Hunt's ketchup or Heinz ketchup? They're both ketchup. Which one's better? Well, whichever one you prefer. Which one costs more? You know? So, yeah, that's kind of how certificates work. Thanks for finding that. That's where we were at. So, RSA is one of those asymmetric algorithms. It has a public-private key. So that way when I go to my bank, my browser very quickly can verify that, yep, that's a valid key, and I can surf the internet. Okay? We check the key repository, kind of like I went up and downloaded Donovan's key, and we use the private key to decrypt it. Okay? Key size. Says when developing them, the larger the key, the better, don't you think? Okay. So that's kind of a confusing. I'm going to give you a Ken Dewey, much easier way to understand this. So if I have one key, do you think you could open that lock?
Yeah.
I mean, yeah, one key. Done. So my key space is 1. Now I got 2 keys. Can I still open the lock? Yes, but it's going to take me twice as long. So now, the odds, I could pick the first key. You ever watch Amazing Race? Someone had to watch Amazing Race. Well, they did a thing once where they gave them this big old ring of keys. They have to open up all these locks. So they have to keep trying each one. Same kind of thing. With 2 keys, I can still open it, but I could take longer, twice as long. 3 keys, could we do it? Begin now to see if we can take longer. So my key space is growing. The number of possible keys is now growing. 4, 5, how about 10? How about 50 keys? So if I give you 50 keys, can you get in that door? Yeah, but you technically might have to try all 50 of them. So someone's trying to break into your house. Can you imagine if there's only 50 keys for cars? That's it. Then the odds are you could go through Walmart parking lot and get into
a few cars.
Yeah, a few cars. So let's talk about binary real quick. That's a 1. Then 1's our maximum number. Let me bring up Notepad here real quick again. Let's go to decimal. You all know how to count? 1 through 10. You all know that. So I start 1, 2, 3. What happens when I get to 9? Well, 9's the maximum number we have. So we change it to a 0 and put a 1 in front of it. That's what we do. Make sense? So when we get to 19, 9's the maximum number. Change it to a 0, increment the next number. So that's how we count. Believe it or not, that's what you do. So what happens when I get to 99? Okay, this was the maximum number, so change it to 0. Increment this guy. Whoop, that's already at the maximum number. Change it to 0 and put a 1 in front of it. That's the way we count. You just don't realize that what you're doing. When binary, we only got 2 numbers. We're at the maximum number. We have 0 and 1. That's our choices. So change it to a 0. Increment the next number. Just like we do in decimal. But instead of working with 10 numbers, 0 through 9, we're working with 2 numbers, 0 and 1. So increment the next number. Now they're both at the maximum number. Change them both to 0, increment the next number. Just like, there's nothing difference. No difference at all. Alright, so let's continue on. So 2 to the 1 is 2 possibilities. So 1 or 0. Okay. 2 to the 2, in other words, 2 to the second power, which is 2 times 2 is 4. So we could have both zeros, a 0 and a 1, a 1, a 0 and a 1 and a 1. So far, so good. So 2 to the third gives me 8 possible. That's 2 times 2, which is 4, times 2, which is 8. Okay? So what would the 2 to the fourth be? 16, exactly. So with 2 to the third, we got 8. So it's all zeros, a 1. You see how that's all the possibilities we could have. So if we had, that's our key. So the fourth is 16. So 8 would give us 256 chances. So if I had an 8-bit key, it's 256 keys. So a 25-bit key, that's a lot of numbers. So would a 25-bit key be good enough, you think? That's pretty darn big. Okay, you know what? How about a 40-bit key? How about a 56-bit key? Now we're talking DES. This is DES encryption. But you can't see it on top of row state. But that is the number of possible keys to break DES. Could you break that? Well, let's see, we got millions, billions, trillions, and a couple things after that, whatever the next numbers are. Sextillions or whatevers. So 56-bit key is a lot of different keys to try. Okay? But you know what? How about a 128-bit key? So if you were going to protect something of yours, would you feel safe using that many keys to get into it? Yeah, that's a lot of darn... Even though we have fast computers, that's still a lot of numbers. You know what? How about 256-bit key? That's huge. How about a 1024-bit key? So is that enough to... You can get a 1024-bit PGP key for free. Totally free.
Isn't that a kilobyte of data right there?
Yes. Yeah. That's a lot of possibilities. So think of, again, how many keys did it take to open that door? Well, that's how many keys we got to protect that door. That's a lot of keys. Yes, someone could have guessed the key on the first try, but maybe not. Probably not.
That many keys would probably be like 50 or 100 pounds of metal.
Yes. There's 2048-bit. It's a lot of darn keys. Okay? So let me go back real quick. Like they say here, a 512-bit key, according to them, is going to take this many years to try it. Okay, estimated average time to crack it. The problem is there's something called Moore's Law. Anyone ever heard of Moore's Law? Moore's Law said every 18 months, the speed of our computers doubles. Think about it. What happens every year? A new phone, a new whatever. Every year or 18 months thing. The prime example was last year when they came out, actually not last year, the year before, when they came out with a new MacBook. They showed the prior MacBook on the screen. Then they showed the new MacBook, the CPU, and it was basically the entire motherboard was less than half the size of the prior one. That was a perfect example. So what did they do with all that space? They put in a bunch more batteries. So now your battery lasts longer. So what's going to happen this year? It's going to be smaller yet, and smaller yet, and smaller yet. Okay? I mean, come on, think about these phones. They do so much. The iPhone 8 supposedly is coming out this year. There's all kinds of speculation what it's going to do, but it's like crazy the amount of stuff that they're doing. So when someone says, oh, that's only a 1024-bit key, that's still an awful large darn key. Okay? Now there's 2048. Look at how big those darn numbers are. Okay? All right. So, cryptographic tools. Okay. So we want to hide stuff. We want to encrypt messages. Okay? So if I am running a website and all I have on there is a picture of cats. Cats is a popular thing on the internet if you did not realize this. So do I need to encrypt my website if I just have cats? So if you search for cats on Google, it's going to send you to Kendo's website because he's got a lot of cats. So I don't see any need to encrypt it. But did you know that every single search you make on Google is stored? Every search. It's never deleted. Somebody out there wants to know who's surfing cats. If it's not encrypted, now they know who's surfing cats. It's me. Okay? So it's kind of one of those things, And the way a network works, which you might have learned about this if you had network class, I don't know, but there's something called the three-way handshake. That's how TCP works. Well, SSL is actually a five-way handshake. So we're adding more to it. So if we're adding more data, obviously it's going to be slower. So, but again, our networks, there was about 3 years ago now, this guy working for Cisco perfected using current technology 3 years ago, was able to transfer an entire DVD movie from California to Germany in 7 seconds. Can you imagine when that actually gets fully out there in the market? I mean, they're talking about not LTE. It's 5G's coming out, and 6G is already talking about that, where it's going to be. I mean, AT&T right now, no more overage. I have a 6 gig plan. I use none of it because I have Wi-Fi everywhere. What happens when I run out of my 6 gigs of data? Anyone know with AT&T? They just slow you down a little. That's all. No more overage fees. No more nothing. They don't cut me off. Everybody's doing that now because it's getting so fast. Compression's getting so good that it's just crazy, and it's crazy. Okay, so we can also use it to verify contents of messages. It says tools must embody cryptographic capabilities because it's just everything needs to be encrypted. That's the best option. Okay, PKI. That's kind of what we've been talking about. It's the public key infrastructure. That's the entire certificate authority, the infrastructure to get the keys. I remember way back when I first started doing keys, I was putting up the website for the 1st Marine Division. Okay, their website. Well, it's funny, they needed a certificate. So I went ahead and request. The way the certificate would work is on my server, I would generate the certificate. I would go to VeriSign or whoever, and I would present them the certificate, fill out all the information, pay them the money, and said, okay, here you go, I want the certificate. Then they would process it and send me back their certificate so that I could put it into my system to verify. Okay. Well, it's funny because I got the request from, it was a VeriSign or whoever, Komodo or somebody, and said, all right, I need you to verify 1st Marine Division. We need a letter from corporation. We need something to prove their identity. I'm like, well, crap. So I went ahead and contacted them and said, okay, I need some sort of proof. Like, I gave them a list of what I need. And they said, well, it's going to take a couple days. 3 days later, they approved my certificate. And I never sent in the information. So what's that telling you? Whoops. Should they have approved it? No, I never sent in proof. That's not a good thing. But, yeah, I was like, are you serious? And it happened with another one, too. Another company I was doing it for, I said, let's give it 3 days. Sure enough, they approved it again. I'm like, are you serious? Now, shortly after that, they fixed it. What it was, there was a problem in their authentication process that they were like, okay, we'll give them 3 days and we're going to prove it anyway. Well, that's stupid. But PKI is an entire system of managing keys. Okay, authentication, we know who you are. Integrity, hasn't been manipulated. Privacy, authorization, non-repudiation. You know what? I know you did this. Okay. So you log into D2L to take a test. You screw it up. And they contacted me and said, oh, dude, I didn't do that. Yeah, you logged in. So I have proof because you logged in. You cannot say that you didn't do it. Now, he could always tell me that, well, I kind of gave my key to him. Well, then that throws it out of the water anyway. But the point is, non-repudiation is you can't say you didn't do it. Okay? All right. We have a certificate authority, kind of like the VeriSign, the Komodos, whoever. We have a registration authority. We have actually certificates, and we looked into some of those a minute ago. There's policies and procedures, which I told you they aren't always good. There's also tools to manage all this, but it's an entire system. So that's what PKI is. Digital signatures. It says create in response to rising the need to verify. So there's a lot of things you need nowadays that you don't have to sign. Does anyone know at least what one of the things are that you actually have to sign? A mortgage. A mortgage cannot be signed electronically. Now, all the applications and all that can be, but the actual mortgage document must be signed on paper because a house basically could be a house for years and years and years, and it could go through 15 generations. They need to be able to track it back to where it came from and who bought it and who owned it, and that's one of the few things that actually have to be signed. Okay, so digital signatures, I mean, anyone here follow taxes yet? Any of you old enough? Do you actually sign your taxes anymore? No. Now I do have to sign mine. My identity was stolen. So for the next 5 years, I actually have to hand sign my taxes and submit them with a special PIN they give me. Every year they send me a new PIN. But, so that's, what digital signatures are to verify that. It's an asymmetric encryption process, great, to sign them. Non-repudiation, I know you did it. Okay. And we have the digital signature standard. Certificates, we kind of looked at those already. Those are proof of who you are. We saw the certificate for Rose State. We know it's Rose State. We saw their address and all that on there. Okay, here's an example of it. Inside of our browser, under Internet Options, we can actually even see the certificates that we know of. Okay, actually, we got a few minutes. Let's go to Control Panel. Let's find it. Internet Options. Let's go to Security. Security. No. Which one is it? Darn it. Or is it Connections? Certificate. There it is. Okay. So I can go in here and I can say Trusted Root Certificates. So if I look in here, VeriSign's in here. Okay. So if I look at this right here and I open up their certificate, I can see that VeriSign themselves, their certificate is good until 2036. Long time. I can see the details of it. I can see what the encryption level is. I can even see, well, obviously they're themselves. And these are root authorities. These are beginning. Now, I sold thwart certificates for a while. Let's see if Geo Komodo is in here. There's GoDaddy, GeoTrust. There it is, right? Where'd it go? I saw it. I know it was there. GeoTrust. I did those. Yep. Ooh, Komodo's even a root authority now. When I originally sold them, Komodo was not a trusted root authority. They were below GeoTrust, so I had to install GeoTrust certificate and then Komodo's certificate. So if you looked at my certificate path, it basically said 1st Marine Division, if it was them, Komodo, GeoTrust. So it was actually 2 steps. Okay? But yeah, these are the people that can issue certificates. Then we also have intermediate authorities. GoDaddy's in there as well. There's lots of stuff. So, and just lots of stuff. And we should be able to see, there should be a certificate revocation list in here somewhere. Somewhere in here there'll be a certificate revocation list. I don't know exactly where it is, but it's certificates that are no longer valid. Okay? So that's kind of what they're showing here. Okay. All right, and that's actually just where we were at. Okay. X509 is the current standard. Actually, it's been a standard for a very long time. Man, we're talking since like 2004, 2003. It's been a long time. And SSL, which is what we use for the internet, has been around just as long. SSL is now being replaced with TLS. TLS is backwards compatible for SSL, even though some people think it isn't. It is. So it's just an encryption protocol we use to surf the internet. Okay. Hybrid systems. It says accept digital certificates per asymmetric is not widely used. Normally, what happens most time is we end up using a combination of both of them. And to get keys listed there, we use what's called Diffie-Hellman. You'll learn more about that in the other class. But Diffie-Hellman is a way of getting you a key. So he's over in Russia. I'm here in the United States. I can use Diffie-Hellman to actually transfer the key to him over the open internet. No problem. It's kind of crazy. Yeah, it just works. Okay. And there's what they're showing. And basically, it's concept. Okay. Steganography. I don't know why it's really in this chapter, but it's kind of like hiding stuff. It's hiding stuff inside of other stuff. It's hiding stuff in pictures. You can do a huge project on this in the digital forensics course. The art of secret writings. You can hide stuff in pictures. You can hide stuff in CDs. You can hide stuff in DVDs. Okay. Hide stuff in WAV files. So we do a big old project in there. Protocols. It says most of the software currently used to protect the confidentiality are not true cryptos. They're just different protocols. Okay. And there we go. SSH, SHTTP. Yeah, that is being replaced. This book won't talk about it, but it's being replaced with TLS. It's the newer version of it out there. Okay. It's secure socket. It's how we surf the internet. Okay. You can also secure your email with PGP. S-MIME. So you can actually encrypt email. It's not done very frequently, but it can be done. Okay. PGP, like it talks on the bottom, is what Phil Zimmerman made. Uses the IDEA cipher, and it's excellent. Works great. Again, if you read that book, you'll learn a whole bunch more about that. I was watching 24 with Jack Bauer. I've never seen that show. I reference a lot of movies and shows if you haven't noticed. But I still remember one of the episodes of that show. They have to break this encryption. Oh, that's encryption with blowfish. I happen to know the secret back door. I mean, yeah, whatever. It's just funny stuff like that. Okay. So there's SSL. There's also something called secure electronic transactions. Was going to be used here. Never got used here. It was used in Europe, though. But it's kind of not used. It's done. It's pretty much gone. Okay. Use this, but yeah, it's pretty much gone now. So, wireless networks. WEP, wired equivalency privacy, is their original, and I'll tell you, when I first looked at the slide, it was actually 8002.11 instead of 802.11, so it was a typo in it, but I fixed it. But WEP was a very early attempt to encrypt our data. Didn't last long. WEP can be broken within seconds right now. Okay, WEP was replaced by WPA and WPA2. They both used what's called the RC4 cipher. WPA is WEP, but the key changes. See, WEP used the same encryption key. I mean, if you use the same key all the time, you can break the key. WPA used a rotating key, but still it was a rotating key from a certain set. So again, it can be broken again. Okay. And we have WPA2 and a lot of stuff beyond that. We also have Bluetooth, all different ways of communicating. They say in here, and they talk about WEP and don't use either one of them. I put the red on there. Don't use WEP or WPA ever. WPA2 is the standard now. WPA2 personal is perfect. Use that. It's included in, unless you got like a super old router or something. Yeah, but WEP, no, it's not good. Don't do that. Okay. IPsec, Internet Protocol Security, is a way of encrypting data. Works with PGP. Also works with our VPNs. Okay. They talk about a bunch of different protocols on here. So they talk a little bit about IPsec headers. It's a way of encrypting our data. Right? Are we talking about VPNs? I don't think we can talk about VPNs here, but there's PGP with Phil Zimmerman. Came out in '91. Said combine best available cryptographic algorithms to become open source de facto standard, and the government did not like it because we were going to encrypt stuff that they couldn't decrypt. Kind of funny. Okay. So, and it's still used today. Okay. So, we have an entire course on this chapter called Cryptography. Yeah. So, I'm assuming you're all going to take it anyway. You don't really have a choice in the matter. But, any questions on cryptography? Okay. All right. So, your homework's pretty simple. I even showed you a website you can use to do it for you. Just know how to do it. What I always tell people is, I got a couple minutes here. I went through a training class with FTK, a software we use. They showed me how good it was, which it's very good. Then I went through the same sort of class, but for a different piece of software called Ncase. So, FTK people, they said they were the best. So I asked Ncase, are you guys better? They said, we don't know. You decide. Which was kind of neat. They didn't toot their own horn. But what I liked about the way Ncase did it is their tool does everything for you. But before you could use the tool, you had to do it by hand first. So you need to know how things work. Okay, I used to work on jet engines. I knew everything there was to know about jet engines. Can you imagine not knowing how they work? I'm assuming a lot of people drive cars and don't have a clue how they work. That's true. But can you imagine if you don't have I was talking to someone the other day, had no clue. Actually, it was our secretary downstairs. She goes, I have no idea how to change a tire. I would never be able to even do it. What? It wasn't you. It was Stephanie. No. But I know. No, her point was she drives, but she doesn't know how to change a tire. Does anyone here not know how to change a tire? No one's going to admit it. Yeah. It's not something we do all the time. You know what I did with my stepkids? It was funny because we had to rotate the tires. And the place wanted $16. I'm like, heck no, do that ourselves. So I went out with the kids. I said, all right, we're rotating the tires. And they were all not happy until I pulled out the impact wrench. Oh, then they were fighting over, I want to do the last tire. But basically it's a real basic skill you need to know how to do. So the whole point of this here is, I showed you how to use a website to do it for you, but you still need to know how it works. Because what happens if that website's not available? That's kind of... Can you imagine you're this big forensics investigator, I'm going to go to court. All right, Mr. Dewey, how did you prove that? Well, I clicked go. Can you imagine if you went to court and said, yeah, I just brought up Ncase and hit start. But what did it do? It gave me the answer. But how did it do it? I don't know. I clicked start. You can't, that's not going to work in life. You can't just say, oh yeah, I just said go. No, you need to know how it works. So even though I show you things like that, you really need to know how to do it. Even AES, when you take that class, you are literally going to be walking through the entire algorithm by hand. And you're going to hate me. But it's not hard. It's just a bunch of little steps. Okay? So that's cryptography. I think one of my favorite, that and forensics are my two favorite courses ever. So I'm teaching this summer if you want to take it. So, all right, that's the end of chapter 8.